Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate what are power functions? Well, a power function is a function that follows the form y equals a times x to the power of n, where n is a whole number, which, if you remember, is like 1, 2, 3, ... No negatives, no fractions, no decimals, okay? But this is a power function. It's one term. There's a coefficient. It's 1 or 2. The coefficient can be any kind of number. But the power has to be, the exponent has to be a whole number. And that's it. That's a power function. So on the right side, you can see I have examples of power functions. Some of these you've actually seen before and you've played with and studied. Some of these we're going to get a little more in depth with this year. But let's look at them. So let's look at odd power functions to start. So all that means is the exponent is an odd number. 1, 3, 5, 7, 9. So let's start with this one. So here is an odd power function, x to the power of 1. That's called the identity function, by the way. So what happens if I put it to the power of 3? Okay, so there's a little change. What if I put it to the power of 5? And then what about 7? Okay, it's starting to change a little bit. What about 9 or 11? Now, do you see the overall shape is very similar? Okay, do you see the ends kind of behave similarly, like they're all kind of pointing in a similar direction? So this is the general shape of an odd power function. It kind of has that shape that looks kind of like a cubic function. So we're going to sketch a cubic. Now they all go through the origin, so that's important to note here. But here's what I really want you to pay attention to. As the exponent increases here, do you see how the curve is getting farther away from the origin? It's almost like the center is flattening more, but here's the thing, it only goes through the origin. Every single one of these only goes through the origin, even though it looks like it goes through other points there. But it flattens as it gets towards the origin itself there as the exponent increases at an odd power. So we're going to draw another little sketch here. We'll kind of flatten it a little bit. And then we'll draw another one, just so we have it in our notes here. So let's talk about a few quick characteristics. The domain of all of these is going to be all real numbers. Now, the range, if you look vertically here, it's going to extend all the way up to the positive side, positive infinity side of the y-axis, and the negative infinity side. So the range is also all real numbers. Now let's talk quickly about behavior. And let's turn off some of these. Let's focus on, let's say, x to the 5th. It doesn't really matter. So if you notice on this function here, if I pick a point here, watch the x-coordinate. So as my x-coordinate increases, that means on the negative side it's becoming closer to 0. Okay? Notice my y-coordinate is also increasing. That means it's getting closer to 0 because it's on the negative side. And then it's going to get to the origin 0, 0. And then when I continue on this side, notice the x-coordinate is increasing and the y-coordinate is increasing. That means it's always increasing. Now, this is true even if it was reflected. So if I put a negative in front, it's going to reflect. Now watch its behavior. Now it's always decreasing. What this means for these type of power functions, these odd power functions, is they will always increase or decrease. They cannot do both. It's either increasing or decreasing. Okay? So this is odds. Let's look at evens here. So I'm going to turn some of these on here. So of course x squared is our nice parabola. Here's x to the 4th. Now watch what happens as I increase the power by evens. X to the 6th, x to the 8th, x to the 10th, x to the 12th. Notice it's doing that same thing that the odds were doing. It's getting flatter around the origin as the degree increases. It's almost like it's getting wider. So let's do a quick sketch. We'll start off with our nice parabola. In the center, goes to the origin, and then we'll kind of go a little bit wider, and then maybe a little bit wider. So we can see that it's widening at the origin, but it still is going to the origin. So let's talk about domain and range. Domain is all real numbers. Now the range, when I look at this, these graphs only exist on one side of the y-axis. They don't exist on both parts of the y-axis. So I'm just going to say it's restricted. It is restricted, meaning it's not all real numbers. There's only a part of it. And just like before, let's look at increasing and decreasing here. So let's look at x to the power of 6, just as an example, just to pick one of these out. So if I pick a point, notice as my x values are increasing, my y's are decreasing. And if I go to the other side, as my x values increase, my y values increase. So what this tells me is with these even power functions, it's both decreasing and increasing. So it will both increase and decrease. So even power functions behave both ways, increase and decrease, but odd power functions will only do one of those. So actually, instead of saying always, let's rewrite it and say only. It will only increase or decrease.